In this video, I want to show you how to match strings to each other. We'll talk about matching strings in the context of matching DNA sequences and subsequences. Now, DNA sequences are sequences of pairs of nucleobases, but because the other nucleobase in each pair is determined, we will just represent DNA sequences using simple sequences of single nucleobases. So this would be one example of a DNA sequence, and this would be another example of a DNA sequence. Now, we will represent DNA sequences as strings, like that. So this sequence would correspond to this string, and this sequence would correspond to this string. We can define those strings, so read them into Python, and now we can access individual nucleobases using, for example, DNA 1 at 0, so this would be the 0th element of DNA 1, so an A. Or you can go DNA 4 DNA 1, 4 for example, and this is a C because this is the 4th element starting from 0, so 0, 1, 2, 3, 4. Okay. You can access this C, for example, using DNA 2 at -1. Now, here's the task that I want to complete. I want to determine whether DNA 2 is a subsequence of DNA 1, and not just a subsequence, but a subsequence that starts at a particular index. So, for example, I want to ask, is DNA 2 a subsequence of DNA 1 starting at index 2? What do I mean by that? I mean, if I start at index 2, so if I start at index 0, 1, 2, so if I start at this G, is DNA 2 basically matching starting from index 2 to DNA 1? So in this case, the answer is yes, because if I start from index 2, I can read off the GTC here. That's the same as the GTC over here. On the other hand, so the answer is yes. On the other hand, at index 1, the answer would be no, because starting at index 1, this is CGT. If I read off 3 nucleobases, just like there are 3 nucleobases in DNA 2, and this is CGT, which is not equal to GTC. It's not the same sequence. So let me now write the function that would accomplish that. So I'll call it match at, and it'll take the sequence, a subsequence, which we're trying to match, and the index I, at which we want to match. So a sequence is a string, a subsequence is also a string, the index is an integer, and what we want to do is we want to return true, so this is a no, of course, so we want to return true if the answer is yes, and false if the answer is no, so we want to return a Boolean. Let me write the description. So what I want to do is I want to return true if subsequence matches sequence starting at index I, and false otherwise. So what would be an example? So let's just copy over an example that's like that. So here what I did was copy DNA 1 here and DNA 2 here and the index 2 here, and like we said, the answer here would be true. On the other hand, with the same examples, the answer here would be false. We'll come back to the design recipe in a minute. For now, let's try to figure out how to accomplish this task. So if you remember what I did when I checked whether GTC matched to this sequence at index 2 is I looked up the sequence that starts at index 2 and I highlighted it. So what would I do algorithmically? Algorithmically, I would say, okay, I can compare this to this G and this to this t, and this to this c, and if all of those are equal, then I got to return true. So let me write it down in longhand. So let's say that I want to try to match subsequence to sequence at index I. So what's the first comparison that I ought to make? Well, I ought to compare DNA to subsequence at 0, because I want to compare subsequence at 0. What do I want to compare it to? Well, I want to compare it to the first character at index I. So I want to compare it to sequence at I. And I want to make sure that this is true if there is indeed a match. What's the next comparison? So the next comparison is I want to take this t and I want to compare it to this guy, to this t. So where is it? So subsequence at 1 ought to be compared to the thing that comes after sequence at I. So it ought to be compared to sequence at I plus 1. Subsequence at 2 would be compared to sequence at I plus 2, and so on. What's the last thing that ought to be compared? Well, it ought to be sequence at the length of subsequence minus 1, like that, because subsequence contains length of subsequence elements, length of subsequence characters. So if we go from 0, we have to stop at the length of subsequence minus 1. If you remember, this is the usual kind of index for the last element. What should that be compared to? This should be compared to sequence at I plus something. So here we went from I, which is the same as I plus 0, to I plus 1, to I plus 2, and so on. And here we went from 0 to 1, which is 0 plus 1, to 2, which is 0 plus 2, and so on, up to this. So what we ought to do is we ought to add this guy to I. And now we have a certain symmetry here, right? Because this is 0 plus 0, and this is I plus 0. This is length of subsequence minus 1, and this is I plus length of subsequence minus 1. So here we have this many elements, and here we have this many elements, and they're all parallel. Those are the comparisons that we ought to be making. Now, how to accomplish that? Well, here we go from 0 to 1 to 2 and so on up to the length of subsequence minus 1. So that's your basic for loop. Usually we use I, except we already used I here for something else, so let's use j instead. I cannot reuse I without losing the information that's contained in I. So I'll say for j in range of the length of what? Well, I ought to go from 0 up to the length of subsequence minus 1, so the length of subsequence. Another way to think about it is I ought to go through every character in the subsequence and make sure that it matches to the corresponding characters in the sequence. So I ought to go through every character in the subsequence. Now what I ought to do is I ought to compare this guy to this guy, this guy to this guy, and so on. So subsequence at j goes from 0 and up to the length of subsequence. And I ought to compare it to the sequence at I plus j. That's what we're doing here. It's I plus 0, I plus 1, I plus 2, and so on. Here we have the usual game of what do we do if those are equal, what do we do if those are not equal. In this case, what we want to make sure of is that all of those things check out, that all of those equalities hold. Only then can we return true. If any one of those equalities does not hold, that means that there is no match. We can return false straight away. So that's why it makes sense to say if those are not equal, well, we just return false straight away. We don't need to do any more checks. We already know that the subsequence does not match the sequence at index I.